For 30 years, there's a machine which is orbiting our Earth at about 547 kilometers. Traveling at an astonishing speed of 27,000 kilometers per hour, it completes one orbit around the Earth in just 95 minutes. This pioneering machine, known as the Hubble Space Telescope, is one of the most technologically advanced machinery that we have put into our orbit. Hubble has taken sharp and detailed pictures of the birth and death of stars, galaxies millions and billions of light years away, and comet pieces crashing into Jupiter's atmosphere. It has helped us not only make important discoveries about the universe, but also given us insights on the origins and fate of the universe. My name is dmrafi. This is the story about Hubble and the lessons that it teaches us through its magnificent journey. Well, to understand the Hubble telescope and telescopes in general, we need to go back in time and meet Galileo Galilei. Galileo was a famous Italian scientist and astronomer who is known as the father of modern science due to contributions in the fields of astronomy, physics, mathematics, and philosophy. So did he invent the telescope? Well, he did not. But he was the first one to use it for astronomy. You see, the genius that he was, he quickly figured out how to make a telescope and made a powerful one all by himself. Galileo made many discoveries through his telescope, showing us that the moon's surface was not smooth as it was initially thought, but instead rough and uneven. Apart from studying the various phases of Venus, he also discovered that Jupiter has moons which revolve around it. With the help of his telescope, he was able to prove the heliocentric model, which was initially proposed by Copernicus in 1543. So Galileo proved that it was Sun which was at the center and not Earth as it was initially thought during those times. This discovery was so unparalleled that it changed the way we saw the world and paved the way for what we call as modern astronomy. Now fast forward 400 years and we meet an American astronomer known as Edwin Powell Hubble. You see, Edwin Hubble is not just important because the Hubble Space Telescope is named after him, but because he changed the way we knew our universe completely. So he figured out two things. He demonstrated that the universe was much larger than it was initially thought. You see, we now know that the total galaxies in the observable universe are estimated to be in hundreds of billions. However, at that time, which is a century ago, many scientists believed that the universe consisted of only one galaxy, that is the Milky Way, and anything else beyond the Milky Way was just a cloud of dust or nebula as they are called, including this one. All that changed, however, on December 30th, 1924, when Edwin Hubble found evidence that the Milky Way galaxy was just one of the many galaxies, and this small cloud of dust was called the Andromeda galaxy, and it looks like this. Hubble also made the observation that the universe is not stationary. In fact, it is constantly expanding. The very ideas of having more than one galaxy in the universe and its expansion was revolutionary, to say the least, and people saw Hubble as the greatest astronomer since Galileo. Both these men found resistance to their discoveries. Hubble to a lesser degree because science had taken a foothold by that time. Galileo's case, however, was totally different. We all know today that the Earth revolves around the Sun. Basic stuff taught to elementary school children. But during the time of Galileo, people in power and public in general believed otherwise. In fact, they were so sure about Earth being at the center of the universe that they did not even want to investigate it further. You see, their logic was, since from our perspective, the Earth does not seem to move, but we can see the Sun moving throughout the day, so it was quite obvious for them that it was the Earth which was at the center and not the Sun. So they put him in house arrest as they believed that Galileo's theory was challenging the truth. Now, he was perceived as a threat to society and the people in power. He was also accused of corrupting people's minds, especially the young ones. Galileo couldn't fight the system and eventually went blind and died while under house arrest at the age of 77. It took the world 200 years to dump their age-old beliefs and accept the truth. Well, change takes time, but 200 years? Now, as if 200 years was not enough, we discovered that truth was lying in front of us for 2,000 years. You see, Aristarchus had postulated that the planets orbited the Sun and not the Earth over 1,000 years before Copernicus and Galileo made similar arguments. Surprisingly, none of his works have survived. Now let's pause and ask ourselves this question. Should it take 2000 years for truth to be accepted? Especially by a species like us which claims to be intelligent. Well, some people may say, these people were geniuses and way ahead of their time. But we all know no one is born ahead of time. Even if it turns your world upside down, the time for truth is now, not tomorrow, and definitely not after 2000 years. So the lesson that we all should learn is to put scientific facts and intellectual freedom above everything else. And just because the vast majority believes in something, that may not necessarily become the truth, because truth mostly comes in the voice of a lone person and not in the voice of a mob. Think about it. Read the history. Now coming back to the telescope, Edwin Hubble's discoveries really generated excitement in the scientific community. Now these discoveries provided hope that we can now finally know the beginning of the universe and all that it contained. And for that we needed telescopes. So bigger and better telescopes were being made. In 1946, Yale University astrophysicist Lyman Spitzer Jr. introduced the idea of a large space-based telescope. And for 2 decades he very passionately lobbied for this concept. But what is the need for a space telescope when we have ground-based telescopes? Well, if your aim is to observe the origin and size of the universe, then ground-based telescopes have got a small problem. Well, actually it's a big problem. And this big problem is our atmosphere. You see, the Earth's atmosphere blurs and distorts the light coming from the stars. So even the most precise and advanced telescopes on the ground can't escape this phenomena. Everyone knows this rhyme, but do stars really twinkle? They don't. What looks like a twinkling star to our eyes is actually light that has been distorted or bent by the Earth's atmosphere. So what you see is not the reality. So basically, if you don't want pictures like this, instead you want this, then you need to take the telescope above the Earth's atmosphere into the space. And secondly, ground-based telescopes cannot observe infrared and ultraviolet light because these lights are strongly absorbed by the Earth's atmosphere. And this is where we take our second learning. Now we all know that the Earth's atmosphere is important for us to live and to survive. It protects us from harmful radiation, heat of the sun, and also makes sure that we have air to breathe. And this is why we can make an interesting analogy of the Earth's atmosphere with our belief systems. When I say belief here, I'm going with this definition of belief, which is an acceptance that something exists or is true, which in reality may be true or may not be true. And our belief system is an ideology or set of principles that help us to interpret our everyday reality. This could be in the form of political affiliation, national affiliation, philosophy, spirituality, or religion, or lack of it. And just like our atmosphere, which is important for us to live, our belief systems are also important because they help us make sense of life, help us to connect, give us purpose and meaning, without which we may struggle with existential questions like why are we here, what is the meaning of life, what is the purpose of all of this. And the important thing to note here is that our belief systems are also very deep-rooted due to culture, conditioning, stereotypes, and political views. So just like our atmosphere, which is responsible for giving a distorted or incorrect picture of what lies beyond, likewise our belief systems can sometimes blur our reality because they are not always rooted in facts. So despite what we believe in, it is important to rise above our beliefs and see things for what they actually are, in all its splendor, truthfulness, and nakedness. Of course, only if you are interested in the truth. Now, Lyman Spitzer was able to generate a lot of support from other astronomers for the space-based telescope. NASA eventually came on board with the idea and then began the difficult task of obtaining the funding for the project. But as we know, nothing worthwhile comes easy. See, the space telescope's cost of roughly 400 to 500 million US dollars was becoming a tough sell. And this is where we get our third learning. You see, NASA knew that funding will be very difficult at the current price. So it did two things. First, adapt and innovate. They decided to reduce the mirror in the telescope from 3 to 2.4 meters to bring the cost down by about 200 million. which was approximately half of the expected price. And the second thing which they did is they decided to collaborate. So they collaborated with ESRO, which is now known as the European Space Agency, who agreed to bear 15% of the funding cost. Finally, they got the approval and the funding in 1977, and in 1978, work began on grinding the 2.4 meter primary mirror for the Large Space Telescope. And finally, after 2 decades of work, Hubble, the telescope, weighing an enormous 10,800 kilograms, 13.2 meters in length and 2.4 meters in diameter, was built and ready to launch. On April 24, 1990, the Space Shuttle Discovery lifted off from the Earth with the Hubble Space Telescope nestled securely in its bay. The following day, astronauts released Hubble into the orbit. It had taken Hubble 50 years from inception to deployment. The whole scientific community and people in general were very excited to see what observations Hubble will make. Everything had gone as per the plan. Out of the 10 things that could have gone wrong, nothing had gone wrong. You see, the launch, taking the telescope into the orbit and finally releasing it, these are all complicated matters which require a great deal of human intelligence, precision, training and years of work. But everything went smooth, and the astronauts who went up to deploy Hubble also came back safely. But Murphy's Law is Murphy's Law. So right when you think nothing can go wrong, something will go wrong. And wrong it did. There is still a lot more to the story. So the journey has just begun. See you in the second episode, and thank you for watching.